Yes, dear student. In last video I told you about application of first law in which I discussed cyclic process, isolated system, isobaric process in which I gave a numerical on boiling of water. Now I take here isochoric process, the process which takes place in system at constant volume is called isochoric process, that is delta V0. If delta V0, then from first law of thermodynamics, that is this, delta U is equal to Q, means whatever the heat is given to system, then that will be equal to change energy. If heat Q is negative, means it is given. In delta Q negative means if delta U is less than 0, it means UF minus UI. It means UI less than UF less than UI. The energy will decrease. So this was our isochoric process. Now I come to two processes which are very important in physics, and we keep on discussing about them in thermodynamics as well as at other places also, heat engine, etc. One is here isothermal process. Isothermal process. Process which takes place at constant temperature. So if during a process temperature of system remains constant, then process is called isothermal. If temperature of system during a process remains constant, then the process is isothermal. Isothermal. And therefore from first law of thermodynamics, we have delta U is equal to Q minus W. In case of ideal gas, internal energy depends upon absolute temperature. Of gas. Absolute means temperature taken on Kelvin scale. Temperature taken on Kelvin. The internal in case of ideal gas. In other cases, if you take liquid, then certainly temperature just now we have proved that during boiling process temp remain constant, but there was change in internal because there is also potential energy. Because molecules have, liquid have force of attraction. So this case I am taking here in case of ideal gas. Actually, concept of ideal gas states that there is no force of attraction, and if there is no force of attraction repulsion, no potential, the energy will be totally kinetic. So absolute temperature. In case of ideal gas, so internal energy depends on absolute temperature. So if temperature of gas does not change, then delta U will be 0, internal will not change, and therefore Q equal to W. Whatever the heat is given, that is used in doing work by the system. This is important thing here to note that internal energy of ideal gas depends entirely on its temperature. We will learn later on. Now I come to here adiabatic process. Adiabatic process. Adiabatic process. If during pressure, during the process, in a system, heat neither given nor taken, if a process takes place when heat is neither allowed to come in or go out, then the process is adiabatic. If we take gas in a system where walls and bottom all are bad conductor, from all sides it is I should say isolated. Here gas is there, all bad conductor. Will anything will be so perfect? Oh, that is another thing. But if process takes place and heat neither allowed to go out nor to come in, then process is. So, and from first law, of thermodynamics, delta Q is equal to delta U is equal to delta Q minus delta W. So Q is equal to delta Q 0 here. So delta U is equal to minus delta W. So how thus, if we take some liquid in a thermos, if we take some liquid in thermos and we shake it rigorously, we shake it continuously at random, very fast process, then work is done and the temperature of liquid in the thermos will increase we are doing work on system. तो work done on system negative, तो negative positive. So temperature will rise. And if we allow a gas to expand, then work done by system, then delta will be positive, so internal energy will decrease. For example, if you allow the air inside the tube by opening valve abruptly, then air coming out is found to be cooler. The temperature of air get decreased because work has to be done by system of positive, so minus sign means delta U will decrease, so temperature will decrease. So these are some processes like this. Now last application, relation between molar heat of gas. The molar heat of gas are taken at constant pressure and यानी कि relation Cp minus Cv equal to R. R is gas constant, universal gas constant. Though you have not learned, but take it granted that we know Pv equal to nRT. P pressure, V volume, R gas constant, temperature and number of moles. So Cp, Cv are molar specific heat here. Cp is the heat, molar heat at constant pressure, which is equal to the amount of heat given. Amount of heat given to system, to gas. 1 mole of gas keeping pressure constant. Constant Cv, molar heat of gas means heat given, heat required to a temperature 1 mole of gas at constant volume. Let we have n moles of an ideal gas. If Cv be the molar specific heat at constant volume, then heat taken by gas to raise its temperature by delta T. Q1, I write Q1 equal to NCV delta T. And from first law, delta U equal to Q minus P delta V. Here volume is constant. Here delta V 0. So in Q1, so delta U is equal to NCV delta T. This is the equation 1. Means whatever the heat given, that is the temperature only. Now, if we heat gas at constant pressure, so we have applied here first law. Now, if n moles of ideal gas is heated at constant pressure. Constant pressure. Then to raise temperature by delta T. So that Q2 and Cp delta T. Cp is the molecular constant, volume pressure. Sorry. Now pressure is constant, volume will change. So from first law, delta U is equal to Q2 minus P delta V. Here delta U to from 1 is using equation 1 and Q2. Here we get and Cv delta T equal to and Cp delta T minus P delta V, or you can write it as n bracket Cp minus Cv into delta T is equal to P delta V. From ideal gas equation we know, from ideal gas equation PV equal to nRT if temperature is by delta T, if delta T be the increase in temperature at constant pressure P, constant pressure P, then equation 2 and 3. Equation 3 can be written as pressure constant but volume will increase when temperature increase by delta T. From equation 3 and 4, subtracting 3 from 4, we get P delta V equal to nR. Putting this value in equation 2, so we get, putting this value in equation 3, and Cp minus Cv delta T is equal to nR, delta T is sorry, nR delta T. So delta T cancel, so we get Cp minus Cv, Cp minus Cv equal to R. So these are application of first law of thermodynamics. Now I will come in the next topic, when rising temperature is there, so heat required are called heat Cp-Cv. How Cp-Cv will actually practical value and theoretical value मैच करनी होती है. So we will discuss in next video about degree of freedom and molecular heat at constant pressure and volume. Thank you.